Hello, I want to talk to you about light. Isn't light beautiful? You know that sun behind me, that beautiful bright sun, the light that's coming from that sun left the sun over 8 minutes ago. So we cannot see the sun in real time. We can only see what the sun looked like 8 minutes ago. Imagine the farther we look into space, the more interesting and farther back in time we can go. So let's explore light. Fossil light. In the vast cosmic ocean, there are islands of light. This light does not reach us immediately. Light travels at 300,000 kilometers a second. The universe tells its story mainly through light and other wavelengths of the electromagnetic radiation. Note that a light year is a measurement of distance and not time, as the name might imply. A light year is the distance a beam of light travels in a single Earth year, which equates to approximately 9.7 trillion kilometers. Named in honor of the trailblazing astronomer Edwin Hubble, the Hubble Space Telescope is a large space-based observatory which has revolutionized astronomy since its launch and deployment in 1990. Far above the atmosphere, Hubble has a crystal clear view of the universe. Scientists have used Hubble to observe some of the most distant stars and galaxies, as well as the planets in our solar system. Hubble's successor, the James Webb Space Telescope, will find the first galaxies that formed in the early universe and peer through the dusty clouds to see stars forming planetary systems. Webb will not actually orbit the Earth. Instead, it will sit at the Earth's sun L2 Lagrange point, 1.5 million kilometers away. So how long does light take to reach us from familiar objects? The Moon, 1 1/3 of a second. The Sun, 8 minutes. Mars, on average 12.5 minutes. Jupiter, 44 minutes. Pluto, on average 5.5 hours. Alpha Centauri, 4.3 years. The giant star Betelgeuse, 724 years. Andromeda Galaxy, 2.5 million years. Whirlpool Galaxy, 31 million light years from the Earth. GNZ11 is seen as it was 13.4 billion years in the past, just 400 million years after the Big Bang. Astronomers measure large distances by determining the redshift of a galaxy. This phenomenon is a result of the expansion of the universe. Every distant object in the universe appears to be receding from us because its light is stretched to longer, redder wavelengths as it travels through expanding space to reach our telescopes. The greater the redshift, the farther the galaxy. The cosmic microwave background is leftover radiation from the Big Bang. As the theory goes, when the universe was born, it underwent rapid inflation, expansion, and cooling. This fossil image represents the heat left over from the Big Bang and dates to when the universe was about 300,000 years old. At this time, our universe was just 100 millionth the size it is today. At least 95% of the celestial information we receive is in the form of light. Because of this fact, astronomers have devised many techniques to decode as much as possible the messages that are encoded in the often extremely faint rays of light. These messages include information about the object's temperature, motion, chemical composition, gas density, mass, surface gravity, shape, structure, and more. Roughly 85% of the information in light is uncovered by using spectroscopy, is one of the fundamental tools of the astronomer. Spectroscopy involves spreading the light out into its different constituent colors and wavelengths and analyzing that spectrum.